Hello everyone, welcome back to Python's AI Talk. I hope you all are doing amazing. Today is day 5 of our generative AI journey. Before we write even a single line of code, let's talk about a big secret in the AI world. Real real world data is incredibly messy, right? When you work at a top tech company or build your own AI application, nobody hands you a perfectly clean Excel sheet. You will find missing values, empty cells, and a lot of raw text information. So, now here is the catch: AI models are essentially giant mathematical calculators. They don't know what to do with an empty blank cell, and they have absolutely no idea what text words like male, female, or mean. They only understand numbers. So, in today's class, we are going to learn exactly how to fix this problem step by step. Today, we are going to learn missing value imputation using KNN imputation for both single numerical features and multiple data frames. Then, one hot encoding using pandas get dummies alongside optimization techniques va np dot where label encoding using Scikit-Learn's LabelEncoder and native Pandas categorical codes. And by the end of this session, you will understand each concept with practical coding. And don't worry if you are a complete beginner, because I will explain everything step by step in a very simple way. So let's get started. Before we click run, let's understand why we are learning this. Imagine you are organizing a giant library and you discover a classic book, but unfortunately, a few pages are torn and missing. How would you guess what was written on those missing pages? You wouldn't just guess randomly, right? You would look at the pages right before it and right after it. You look at closest neighbors to understand the context. In data science, we face the exact same problem. Columns like age or salary often have missing values. If we simply delete those rows, we lose valuable data. If we blindly fill them with a basic average, we might run the true patterns. That's why we use K-N imputation, which stands for K nearest neighbors imputation. Awesome. Now, before we build any smart data pipeline, we need to gather our tool. Let's move to the next. We are going to import our core data science libraries: NumPy, Pandas, Matplotlib, and Seaborn. Think of this exactly like a professional chef setting up their kitchen counter before they start cooking. They lay out their knife, pot, spoon, and spices so they don't have to look for them later. Here we import NumPy as NP for mathematical calculation and Pandas as PD to read and handle our data tables. We also bring in Matplotlib and Seaborn, so that if we want to draw any visuals charts later, our environment is fully ready. So let's execute this. Perfect. Now let's move to the next core cell. We are just ensuring that our pandas library pointer is active and loaded as PD without any hitches. It's like checking your backpack one extra time before heading out to make sure your absolute best friend panda is right there with you. Let's run. All right. Let's move to the next. We are going to load a dataset that you all know and love, the classic Titanic dataset. We use the command pd.read underscore csv and pass the file name Titanic dataset. This reads the file and save it inside a variable called df. Right, below that we call df.head. What does .head do? Think of it like a sneak peek preview. It shows us the exact first 5 rows of our dataset so we can see what columns we have. Let's look closely at the screen. We have passengers, classes, name, gender, and age. If you look closely at row 0, the cabin column show NaN. That means not a number, which points out a missing value waiting for us to fix it. Let's move to another cell. Now we need to grab our high-tech data engineering tool from the Scikit-Learn warehouse. We are importing train test split because we want to divide our dataset into training testing portion. We are also importing Canon Imputer from Scikit-Learn Impute. This is the core algorithm that is going to find the missing data neighbors and fill in the blanks for us. Let's execute this. Let's move to another. Here we are simply writing x is equal to df. What we are doing here is pointing our main dataset to a variable called x so that we can easily track our features moving forward. It's like posting a clean layout label onto our data box. Let's run. We just type x on its own and run it. Why? Because as beginners, it's a great habit to constantly print out your variables to ensure your data structure hasn't broken. This is beautiful interactive HTML table. You can see all the records are perfectly aligned and ready for us. Let's move to another. We write x.column. Notice that this is an attribute property, so do not put parentheses at the end of it. If you do, Python will throw an error. This code gives us that exact list and spelling of all our column header like passenger ID, survive, P class, age. Let's execute this. See, here is the index. You can see here is the index that print. Now let's move to the next. We are splitting our data into xtrain and xtest using train test and split. We set test size is equal to 0.25, which means we are saving 25% of our data for testing later and using 75% for training. And we also set random underscore state is equal to 0. Why? Because this locks the randomizer. It ensures that when you run this code at your data split exactly the same way, making our result perfectly. Let's run. Let's move to another. We want to find out exactly where our missing data gaps are. So we write x underscore train dot is null dot sum, flags every empty cell as true and sum, adds them up column by column. Look at the output on the screen. The age column has 133 missing values and the cabin column has a massive 511 missing values. These give us a clear roadmap of exactly what we need to clean up. Let's move to another. Before handling age, notice that the embark column is only missing two values. Here, embark two values. So it's a text column and missing only two spots. We don't need a complex algorithm. We can fix it simply by filling those two blanks with the most common port value, which is S. We use fill NA S and assign it back to the column to save our changes. Let's run. Then we write x underscore train dot info to run a quick diagnostic check on our dataset. Look closely at the non-null. Our training dataset has 668 rows in total. Notice that Embark now show a full 668 non-null values. That means our quick fix worked perfectly. However, age is still sitting at 535. So let's handle that next with Canon. To keep our experimentation clean and simple, let's extract just the age column by writing xtrain and saving it into a separate variable called x underscore 101. This lets us focus entirely on this one feature without cluttering our workspace. So let's run this cell. Let's print out x underscore 1 to see how it looks. Notice how the index, okay, numbers on the left are jumping around like 105, 68, 253 instead of counting straight from 0. Don't worry, that's completely normal behavior because our splitting function shuffle the rows randomly. You can also see the NaN placeholders waiting to be filled. Let's run. So we initialize our Canon imputer and set n underscore neighbors is equal to 5. This tell the algorithm, hey, whenever you find a missing age, look at the 5 closest matching passenger and take their average age. So pay close attention here. So wrap x underscore train, then here is the age inside pd dot data frame. because Scikit-Learn transforms required a 2D table shape to work, and passing a 1D series will cause an error. Then we call dot fit underscore transform. Let's press run. So this is just a cleaner alternative way of writing the exact same operation. Since we already save our age column inside the shortcut variable x underscore train1, we can just pass pd.dataframe and x underscore train1 directly into our imputer. It produces the exact same result but keeps your code looking professional and readable. So let's run. And let's verify if our single column imputation actually works. We convert our output array back into a pandas. Data frame and run is now some. Look at the screen. It show exactly 0 missing value. Our Canon imputer has successfully handled every single blind spot. Awesome job. So till now we have learned how Canon imputation works for a single column. Let's create the next cell, which is multiple fields. In the real world, columns are interconnected. A passenger age might be highly related to their ticket class or how much their cost. By running Canon imputation across multiple numerical columns, our algorithm can use these overlapping patterns to make incredibly smart calculation. So let's move. We are going to extract a slice of multiple numerical feature together. So here is the age, passenger ID, PC class, and so notice that we are using double square brackets. Remember, as a beginner mistake, if you use single brackets for multiple columns, Pandas will throw an error. Always double wrap them. So let's run. Then let's print out our update x underscore train1 data frame. Look at the beautiful table grid on the screen. We have all 4 numerical columns sitting side by side. The field column like P class, and this column are going to serve as the baseline context for our algorithm to calculate the missing values. In the age column, so let's move to another. Now we initialize our Canon imputer and neighbors is equal to 5 and pass our entire multi-column data frame x train 1 into fit underscore transform. The algorithm will calculate the mathematical distance across all 4 features at once to fill in the missing data gaps with extreme precision. Let's execute this cell and then move to the next. We convert our process array back into data frame and call is null sum. So execute it. Look at that column. 0, 1, 2, 3 all show absolute 0 missing values. Our multiple data cleaning pipeline work perfectly. So fantastic. We have completely mastered how Canon imputation works for single and multiple column. So let's create the next, which is encoding method. There are two methods, label encoded and one hot encoder. So before we test our encoding methods, let's write df1 is equal to df.copy. This creates a completely independent self-duplicate copy of our dataset in memory. So let's run this cell. And we are now seeing one hot encoder method. So these techniques take a categorical text column and split it into separate binary columns containing 0 or 1 for each unique category. It is the perfect approach for nominal data where there is no natural order or ranking like gender or city names. So let's see what unique categories are hidden inside our this column. Dot values underscore counts. This is an awesome baseline habit to count exactly how many occurrences of each category exist. As you can see, we have 577 male records and 314 female records. Let's do the exact same check for our fourth column by running df1 and this column and dot value underscore counts. We can see three unique ports here: SCQ, S with 644 entries, C with 168 entries, and Q with 77. Now let's apply one hot encoding using a super handy built-in Pandas function called pd.get underscore dummies. We pass our data frame df1 and target our text column by writing these columns and expand those text field into binary options. So let's run and let's check changes by calling df1.head. So see changes by calling df1 head. Look closely the right side of our data frame table layout. The original text fields are gone and in their place we have brand new columns like female and male split into two columns. Then embark before has only one column like embark. It converts in three parts: C, Q and S. So it's showing true, false. Let's move to the next code cell. Now optimize our features like senior developer. If a passenger this value is false. They are guaranteed to be male, right? We don't need a separate column to tell us that keeping both creates redundant data, which is known as the dummy variable trap. We call df1 drop pass the redundant column like this and this, and then set x is equal to 1 to tell pandas to drop along the vertical columns. So let's run and let's move to another. We write df dot head to check our work perfect, the redundant column are completely gone or not. So let's check. Oh, see, the male column is removed and the embark case is also dropped. So feature space is lean, clean and fully optimized for model training. Right now our new columns contain boolean flags like true and false, but let's convert them into actual machine readable numbers using np.where. This function acts just like an inline if-else statement. We tell it to check our column, and if the value is false, replace it with 0. Otherwise, make it 1. So let's execute. Let's call df.head to look at our original base data frame. So look at that. Original dataset still contains its raw text string. So this proves that our workflow safely protected our baseline data. Awesome. So till now we have learned how one hot encoding works and how to optimize our features using NumPy. Let's create next, which is a LabelEncoder. Unlike one hot encoding, which creates a brand new column, LabelEncoding works by assigning a unique sequential integer to each category inside the exact same column. It is the perfect approach for ordinal column, where categories have a natural ranking or order. So let's see. So another fresh backup copy of our data called df2 is equal to df.copy. By running df2 is equal to df.copy, this gives us a completely clean slide, so we can test label encoding without mixing it up with our previous one hot encoded features. So let's run. And let's move to another. So here we import our label encoder tool from Scikit-Learn preprocessing toolkit by writing from sklearn dot preprocessing, import label encoder. Make sure to use camel case styling here with a capital L and capital E. So our Python will throw an import error. Let's when you use small letters. So let's run this. Let's move to another. So here we initialize our class by writing LE is equal to label encoder. Don't forget the empty execution parenthesis, At the end, this set our encoder object ready to map like our categories. So let's run. So we call le.fit underscore transform and df2 and this column and assign it right back to override the column. The encoder automatically sorts the text categories alphabetically, meaning female will be mapped to 0 and male will be mapped to 1. So let's run and let's verify our transformation using df2.head. Look at this column. It has updated beautifully. Male is now represented as a 1 and female is represented as 0, keeping our data frame width completely unchanged. You can see the difference here. Let's move to then another and let's apply the exact same transformation to our multi-category embark column by running df2 embark and le.fit transform df2 in this column. This will automatically map our port letters to clean sequential numbers like 0, 1 and 2. Let's check. And let's run df2.head to check our progress. Look at the embark column on the far right. It has updated perfectly into clean numbers and our data set is looking more ready for machine learning every step of the way. You can see before is the alphabetical. It's converted into numerical. Let's move to the next course cell. Now let's learn a super cool alternative shortcut using pure pandas. No external library import required. We select our name column, converts its data type to a category by writing dot as type category and then simply extract its internal category integer tracking codes using .cat.codes. This is an incredibly fast way to label encode high features. Let's execute and look at complete table. So I'm for checking df2.head. Let's run. See name column into a clean numbers format. Our data is completely clean, fill, encoded and fully ready for advanced AI and machine learning models. Here is the C. I will show you the name column again. And congratulations everyone. We have successfully completed day 5 of our generative AI journey. So today we learn how to use advanced scan and imputation to handle missing data gaps across single columns and multiple features. We implemented one hot encoding using Pandas git dummies while avoiding the dummy variable trap, and we unlock label encoding using both Scikit-Learn, LabelEncoder and native Pandas category code. So I highly recommend you practice today's notebook at least one more time. If today's class helped you learn something new, don't forget to hit the like button because it really supports the channel. So, in the next class, day 6, we will learn even more exciting generative AI concept. Until then, keep learning, keep growing, keep building. I'll see you in next class.